What is asynchronicity, parallelism, and concurrency in JavaScript applications? This is a topic that we're going to talk about that thanks to Kyle Simpson, one of the front-end master instructor and the writer and author of You Don't Know JavaScript, among other books, where the idea here is, in this course, is to see and understand what are this asynchronous nature and understand the conceptual aspect of this asynchronicity, so we can now put a practice, especially when we need to actually deal with that in our JavaScript application, as a way to provide now to clients and customers this asynchronicity, these features that allows to wait for something and then coming back and make it easy for us to understand. So to write and understand. So the developers, when they see that, they see, all right, now I can understand what you are doing here. Why this is important? Glad you asked, and if you don't, bear with me. Because when we're writing JavaScript applications, right? And if you can imagine that you are building is an application for a company that is an e-commerce that sells TVs, right? So they sell TV, is smart TV. So one of them is sell to Kanye West, right? So Kanye West decided to actually buy some of the massive TV to their mansions. Good. So that's it. So he bought that. Then we suddenly receive a call from the CEO. We're some scary about that, but he say, hey, thanks to our team to actually is moving forward in the way of pushing the boundaries for this company, and also you're gonna receive some sort of compensation at the end of the fiscal years and that kind of thing, right? So he actually agreed with you and all of the team members in the company for doing the best. So you thought that you actually will be fired for some reason, but it turns out that the work that you do, especially when you are now handling is these e-commerce applications, it was something great. Suddenly you receive a call a Saturday 1 a.m. And your CEO is telling you that the application charged 5 times to Kenny in his credit card that purchase. So you want to know why that happened. And then it is okay that you need to actually talk to the credit card to actually roll back this. This is something that can take some days to do that, and but you need to know why that happened in your application. Then you go back to your code, you take a look at that, and then you suddenly realize that, well, we are using this now for the checkout button to actually make these communications, right? Some third-party libraries. So you check your code is good. Then you dive into the third-party library as a way to see what happened there, and then you realize that they are handling this particular asynchronous operations very funny, right? So they actually is now using a callback, for example, using this long or short polling, this communication technique as a way to verify if that operation was processed, but was handled. And then you realize that this is what most likely caused the error here. So now you talk to their customer support as a way to now find a way to see that, hey, you actually have this particular error there. And they call in their developer teams as a way to, well, raise that box as a ticket and be able to implement that feature. So then you come back to your CEO and then you tell these stories like, hey, well, we could find the problem, we could find the bug. It was not in our code, it was in a third-party library, so we called them as a way to notify that this is something that happened in their code. So do you think that the CEO, it will, when they hear that, when he or she hears that, it will be pleased about that? Most likely not. Definitely not. Because he's gonna ask, why in the F are you using that library first? And that's now the moment in where we say, hey, well, we try to elaborate ourselves to, we try to make all of this spaghetti, this conversations, try to make sense with that and try to show them as needed, okay? But the thing here is that we didn't implement that because we just want to rely on this pattern and how that works, and we couldn't implement our own solution because honestly we didn't know how to deal with that kind of complexity. And that's what we're gonna talk about briefly in today's video, is that parallelism and asynchronicity. Parallelism and in asynchronicity, and how by now understanding is this particular pattern, the conceptual aspect of this, and then also the practice of it. A lot of the time, this is now some typical solutions to common problems and how we can come out with it. And all of things are using is callback. So all of these patterns that we're gonna see here, like thongs, promise, generator, coroutine, event reactive, CSP, is all of them are based on how can we now deal with this asynchronous nature. And for that, we need to clarify then what asynchronicity means and what parallelism means in a language from the human perspective and not for the computer perspective. Again, this is a quite big philosophical aspect, but it's something that is needed to understand. So when we say parallelism, okay, as human, we are not able to be truly parallel. Unless you are now, for example, take a look at the biology, which is there are several things that need to happen in our body as a way to maintain that per second or per a fraction of a second, right? Otherwise we will. But in the context of cognitive parallelism, we are not. And that's why we are looking here, because at the end of the day, I am not a neuroscientist, okay? But at the end of the day, what happened is that when we are writing our code or reading it, a lot of the time we do that in sequence. That's why now JavaScript language actually is not only run on a single thread, okay, but also is allow you to run is line by line, okay, as in a script, okay. That's why this is called a script language, similar to Python, and because in our JavaScript application or in modern application, web model applications, we need to deal with this asynchronicity aspect, and especially for computers, parallelism and asynchronicity. Parallelism for the context of computers is that make several tasks make multiple tasks at the same time by splitting them into instances. So by splitting them into threads in your processor. So your processor has some processor have 4, 8, 16, 32. So this is known as true parallelism. That's true parallelism. It's a series of tasks that are passing to all of these different threads, and now they are executing at the same time. However, if you can imagine, your OS, right, is handling only 60 things in parallel or 32 in parallel, is something that's not fit for an OS, because you require a lot of instance or threads to actually run in different and check different peripherals, to check different peripherals, uh, their life status, if you're using a laptop, battery status, as well as some of the application that is running on top of the OS, you know. So you need a lot of this instance to be created. That's why we have now all of these virtual threads. So in the context of JavaScript, right, that is running on a browser, and this browser is a single thread. It uses one thread of your processor of your computer, right? So JavaScript now, as I mentioned before, it allows to describe all of this line by line code or statements, okay, as a way to run these programs. Since doing this with the browser, where now the browser is capable to not only receive all of this HTML, CSS, and JavaScript files and also image and fonts, and also transform them into pixel on the screen, but also is need to run this JavaScript code. When we need to do this, all right. So for the developer perspective, right? Parallelism is about performance, and the reason of doing that is you want to do your tasks. You want to do as much as stuff as you can at the same time. So, because as I mentioned before, true parallelism in human doesn't exist, and the parallelism in computers is all of this different tasks that is running at the same time. Asynchronicity, for the context of the threads, right? Which is the JavaScript programs that run on a single threads. You can only have one single instance per threads or per instance. You can also have calls like web workers that allow you to communicate to this instance or to share data across this instance. But behind the scenes, what it's doing is creating another instance to do that. So even though that this is not parallelism, all right, it's just following the notion with the event loop as a way to now deal with this task asynchronously. In this case, concurrently. So even though that this is not a JavaScript feature, this web worker is a platform feature, right? So you are running now one JavaScript threads on a JavaScript engine, okay? And as long as our JavaScript program concerns, you don't have to worry about its variable sharings or data sharings, and especially in multi-threading programming, because there's a lot of things that you need to know. Is the good thing of that, the good news of that is that you don't have to worry about with things like taxes and shared resource lock-ins and all of the wildness that multi-threading are making that thing capable, running all of these multiple tasks at the same time. uh, for workers is trying to close that gap with the notion of the event loops. And because in the context of writing our applications, when we need to wait for a code to run, to a statement to be called after a certain amount of time, so concurrency now is, unlike the parallelism, which is from the point of view of all of these instances, concurrency is that tasks that overlap at a time. So you are now evaluating this task, and then you suddenly need to deal with this another priority task. So after you finish this, then you overlap this task, and so on and so forth. A good example of this is when your mom calls you while you're cooking, right? So you are actually doing things concurrently, not in parallel, because you're not able to cook and talk to your mom at the same time, even though that you might think that you can do that, but cognitively speaking, is something that is not sustainable. It's not feasible, right? You can do that for a small amount of time, but it is not sustainable. And the whole point of this is to make it sustainable. So concurrency here is now this way of how we're going to handle all of these tasks that are overlapping at time, okay? And dealing with this complexity is something that you're gonna get paid for. This is the reason why people actually hire you, as a way to say, hey, we got now this problem in our e-commerce, in our application, we want us to actually know how to handle this. And this is now a calls to arms to people to actually know how that tool works. That's one of the reasons why I also am doing this course in this video. Know how that tool works, have the discipline to understand them and apply them, which one of the important thing of this is that when we are, if you ever hit the gyms, or if you have kids, or if you have a pet, you know that you have a discipline with them, or whether it is a particular activity or the job or your pets or your kids, right? You have a discipline to them, and that is you must attend them. So pretty much here, the idea is that understand how these things work. We're gonna see how these things work. All right, what are the patterns that allow us to deal with this concurrency, to manage this complexity, okay? And what are the typical solutions for these common problems? So we need to be more strategic and tactical when dealing with concurrency in your asynchronous application. That speaks volumes, man. You need to be strategic and tactical when handling concurrency complexity in your JavaScript or in your asynchronous program. This is not only relevant to JavaScript. This is also applicable to any asynchronous application that you're building in our context JavaScript. There are some concurrent complexity. There are some tasks that you need to handle that overlaps at a time, and then you need to find a way of how you can come up with that. What is the pattern that you see that you can apply with? So callbacks. It all starts with callbacks. So because we are now in the context of JavaScript, right? And here, this is the way of how we can now tell the language, thanks to the web platform, hey, this is a set of instruction that I want you to now do after an X amount of time, and after an X amount of time. So while I'm reading all of this code synchronously, so when I access to this timer, to this timer, okay, then you can do this particular call, right? So you want is to now run these functions after, for example, an Ajax request, you want to run this code after an Ajax request or a web worker, or waiting for a web worker's message. Interesting, something that I am not quite familiar with. That's one of the reasons why I don't recall this web workers API. No, this is web workers. Okay, is this one? Make it possible to run a script operation in the background thread separate from the main execution threads of a web application. So in other words, it's creating this another thread, or using another threads. Threads that are provided by who? You may wonder, who provide these threads? So glad you asked. Perplexity. Are running in a separate separate thread. What does it mean? Responsive user interface, especially when dealing with computationally intensive operations. Key characteristic of a worker: separate execution context. Each web worker is running its own global context and has its own instance of the JavaScript instance. So this is now a separate running its own global context, running its own JavaScript engine. This isolation means that the worker cannot directly access variable or function defined in the main thread, ensuring that they operate independently, communicating via messaging. Hey, this is where you can limited API access. Unlike the main thread, web workers do not have access to the DOM or certain web APIs like local storage. They are assigned to perform computations or handle data processing tasks that do not require direct interaction with UI elements. So for example, anytime you need to process so anytime you need to actually process something in a worker.js, exactly, this is how you create now a worker. And in a worker.js, you can define how the worker should respond to message. Oh, okay. So because it creates now its own global execution context. And then on your main application, or your main JavaScript, you say, hey, on message, I want you to now resolve from worker. Send the result back to the main thread. This is what, can we actually do this thing here, right? So we say, hey, but this is, you need to create is another word. Okay. So the thing here is that you can now delegate tasks. Okay. In the web workers, you can delegate tasks to be done here, especially intensive computations. You can delegate these tasks here for that. So the advantage of this is that laborious processing can be performed in a separate threads, allowing the main, usually the UI threads, to run without being blocked or slowed down. So a worker comes at any usage. A worker is an object created using a constructor that runs a name JavaScript file. As we can see here, actually is creating is a new worker. That's right. And this new worker, what it's creating is now a worker object that execute the script at the specified URL. Okay, I want you to run this script at a specified URL. So by leveraging the notion of event loop, we can now we can now create this multi-threading programming here, right? Without all the complexity that we need to handle in parallelism, like taxes or semaphores or resource log sharing and all that wildness. But this is with the notion of the event loop. In addition to the standard JavaScript set of function, string array object and JSON, you can run almost any code you like inside a worker thread. There are some exceptions. For example, you can directly manipulate the DOM from inside a worker. Exactly, because after all, this is a new instance of the JavaScript engine, but it doesn't expose the API from that, or use some default method and property of the window object. For information about that code that can run, see worker global context and functions, and supported web APIs. Interesting. Background fetch Background fetch API. This is an experimental technology. Interesting. Background synchronization, barcode detection API. Okay, and it makes sense. Okay, but the notion of this, alright, you can also use the fetch API inside of that file API. You know, there's some features that you can have access here. Network information API, push API. Now we can use server send events. This techniques is communication technique. Crypto. We can also make some XHR API as well. But again, since this is now a specific instance of the JavaScript that allow us is to run some heavy computations without blocking the main threads by creating is now a separate threads to this, that makes a ton of sense. Again, this course is not about web workers, but it's just an idea of now how this asynchronicity make things possible. In the context of JavaScript is how this notion of the event loop actually make all of this async operations to be deferred, to be processed later on, to make this callback or to make the continuation of this code do that later on. So we call callbacks as a continuation of the program at some points in the future. This is this is callbacks and continuations. So I'm describing this as a way to understand that when you are now going to define all of these tasks that depend on another, okay, all of this continuation of our codes that will run at some point in the futures, and when that happens, we want us to now run another callback, and when we get the value out of that, run it again, run a next one, and so on, so on, and so forth. A lot of the time we call this as the pyramid of doom, but the thing here is it doesn't solve the problem, or this doesn't address the real issue of this, because you can read this in this particular fashion, or you can read several functions, for example like this, that they're going to call them one after the another, right? And therefore you have now this, right? So we can solve is this callback help problems, but we couldn't is solve so far is how we're going to handle this asynchronicity, is this concurrency. This is something that is not visual for us, okay? So that's one of the reasons why now callback here is not sufficient for handling from, it's not sufficient from the developer perspective as a way to now make it readable and easy to understand, easy to reason about this. And I get it, and I get it, and I get it, and totally get it, totally get it. So this is now the exercise here.
So we're going to do exercise 1, okay? Now, let me orient you to exercise 1, and it's really important that you get this orientation solid right now, because we are going to revisit this same exercise all the way through 7. 1, 2, 3, 4, 5, 6, 7 is the exact same problem domain, revisited in different asynchronous patterns. So starting out with exercise 1, let's open up the README in the ex1.js. Now let's try to get more familiar with what this exercise is asking us to do. And honestly, what it's asking us to do is, I've attempted to articulate a pretty common pattern that we run into, especially in the user interface of our systems. What you're going to be asked to do is coordinate the responses to a set of fake AJAX calls. Fake AJAX, because I didn't want you to worry about setting up your own servers or any of that other stuff, so it's going to pretend to do AJAX. And I've got random delays in there such that every time you run your program, you're going to get different behavior out of it, just like you would in the real world. Okay? But these are fake AJAX. They're not actually making network calls, but it actually doesn't matter to us whether it's fake. What matters to us is that we want to pretend as if we're making calls and respond to the sequence of responses in a sane way. And the way we want to respond to that is, we're going to request all 3 of them at the same time, aka in parallel. We know we really should use the term concurrent. But in parallel, we want to make the same 3 responses at the same time, or the same 3 requests at the same time. Now, when we get a response back from file 1, we want to print it right away. In fact, if we get file 1 and file 2 back, but file 3 is still waiting, we want to print file 1 and file 2 right away. We want to render them as soon as possible. Why? User perception of performance. If we waited until all 3 were back before we printed them, the user's going to feel like the system is slower. But if we progressively render whatever we have, they're going to feel like it's faster. That's a really important component of experience, is user perception. Even if
especially if you want us to know is to handle a very common if you want to handle a very this is a very common pattern here, the asynchronicity here, the parallelism here in your application. So you want to send is multiple requests at the same time, and then when that is solved, right, then you can now is show that data as you get it. Why? Because you want to show something to the user, because this is now how you can improve the user experience as a way to know that something is happening and then you get into something. Okay.
it takes the same amount of time, the perception is important. But one additional wrinkle, which is I want to make sure that those files print in the correct order. So if file 2 comes back right away and file 1 is still pending, don't print file 2 yet. Wait until file 1 gets there and then print in the correct order. The perception. Even if it takes the same amount of time, the perception is important. But one additional wrinkle, which is I want to make sure that those files print in the correct order. So if file 2 comes back right away and file 1 is still pending, don't print file 2 yet. Wait until file 1 gets there and then print both of them. So what we're wanting to do is render ASAP, but in the proper order. You see there's a little bit of a twist here. And that's intentional, and that's correct component of experience as you did them. The user's going to feel like the system is slower, but if we progressively render whatever we have, they're going to feel like it's faster. That's a really important.
Exactly. So this is a very a very common example. A very common thing here that happens a lot of in our UI development, right? Which is how we're going to handle is this call that happen in parallel, right? You're going to want to fetch resource in parallel here. And more importantly, is that, or also, you want to now show this data as you get in here, right? Because at the end of the day, you want to show something to load progressively. Hey, this is what is happening here, you know? You want to improve the user experience, or that makes the illusion that you're gonna get all of the things in parallel, or that you're getting these things that you as a user are getting is the things as expected, right? In this particular fashion. So you have the user perception here when you are now doing all of these parallel transactions, okay? And also you want to show them in order, right? Because okay, you want to show them in order.
Component of experience is user perception. Even if it takes the same amount of time, the perception is important. But one additional wrinkle, which is I want to make sure that those files print in the correct order. So if file 2 comes back right away and file 1 is still pending, don't print file 2 yet. Wait until file 1 gets there and then print both of them. So what we're wanting to do is render ASAP, but in the proper order. You see there's a little bit of a twist here. And that's intent, and then print both of them. So what we're wanting to do is render ASAP, but in the proper order. You see there's a little bit of a twist here. And that's intentional, and that's a generalized statement of a pretty common pattern in user interface design, doing multiple things in parallel, waiting for them to come back, coordinating their responses, responding as soon as possible, but making sure things happen in a sane order.
This is
but
something
in the proper order.
That we're gonna do a lot.
Don't print file 2 yet. Wait until file 1 gets there and then print both of them. So what we're wanting to do is render ASAP, but in the proper order. You see there's a little bit of a twist here. And that's intentional, and that's a generalized statement of a pretty common pattern in user interface design, doing multiple things in parallel, waiting for them to come back, coordinating their responses, responding as soon as possible, but making sure things happen in a sane order. That's what this exercise calls for you to do. So let me orient you to ex1.js. You'll notice I have my fake Ajax. It's mapping from a URL like file1 to some contents, and I've got some random delay in there. I've got an output utility, which is a convenient wrapper on the console.log for you to use. Here's my get file function. It makes that fake Ajax call. And this is the part where you need to start figuring out some code, because it's pretty easy to call get file 3 times in parallel. I gave you that for free. But the question is not how to coordinate the requests. Well, I gave you that for free. This is the part where you need to start figuring out some code, because it's pretty easy to call get file 3 times in parallel. I gave you that for free. But the question is not how to coordinate
the question is that something that, yeah, wait.
Here's my get file function calls for you to do.
You describe something here that we need to do a lot.
Doing multiple things in parallel, waiting for them to come back, coordinating their responses, responding as soon as possible. A little bit of a twist here. And that's intentional, and that's a generalized statement of a pretty common pattern in user interface design, doing multiple things in parallel, waiting for them to come back.
Okay. This is now the exercise. Okay. Exercise. A common pattern in UI development in coordinate. So a common pattern in UI development is
there's a little bit of a twist here. And that's intentional, and that's a generalized statement of a pretty common pattern.
User interface design. It's a common pattern in user interface design. not development. A common pattern in user interface design.
Doing multiple things in parallel.
So a common pattern in user interface design is doing multiple things in parallel, waiting for them to come back, coordinating the response, coordinating their responses.
while waiting for them to come back, coordinating their responses, responding as soon as possible.
Coordinating the responses, responding as soon as possible, and make sure the thing happen in the same order, and make sure that things happens in the same order.
Well, we're making sure things happen in the same order. That's what this exercise calls for you to do.
Holy crap, bro. This is very a common pattern in user interface, or in this case, a common problem that we need to deal with. Okay. Problem. Okay. So a common pattern in user interface design is that, yes, it's doing multiple things at the same time. It's doing multiple things at the same time. For example, fetch requests, doing multiple things at the same time, waiting for them to be, or waiting for them to come back, doing multiple things at the same time, waiting for them to come back, So doing doing multiple things at the same time, waiting for them to call back, or waiting for them to come back. So doing multiple things at the same time, waiting for them to come back, coordinate the response. Doing multiple things at the same time. So imagine this like in a delivery system, right? In a delivery system like UPS or any other direct wall, or UPS, DHL, you know. So they not only is doing or send multiple requests, or doing multiple things in parallel, but also wait for them to come back. And by doing all of these things in parallel, is I saying all of this package, okay? Then waiting for them to come back, waiting the response if all of this package has been already loaded into whatever transportation medium, right? Any vehicles for that? Waiting for them to come back for the response. Now coordinating their response, and coordinating the response, show them as soon as possible, all right, or responding as soon as possible to all of this. Exactly, it's like, hey, all of this bulk of package actually was developed. This bulk of package was now issued to, this bulk of package was issued to truck 1. This small set of package to truck 3. There's another one to truck 9. And the idea is that not only you need to handle, so not only you're gonna send all of these requests, sending all of this, or sending multiple things in parallel, sending multiple things in parallel, waiting for them to come back, coordinating the response, and responding as soon as they get possible, responding as soon as possible, and then show them in order, right? And then organize them, organize all of this in order. That's a very interesting pattern that happened is in a lot of media, in a lot of this coordination plays. This is also, this is not only a thing for delivery services, which is a great example, but it's also for any job that you have to do as well. Yep, for any job that you have to do it as well. And this is where we're gonna handle this. This is now the problem. That's what is important to understand. What is the problem that you're trying to solve? And a lot of the time here in computer science, it's all about that. It's that, hey, what is the problem that you're trying to solve? In engineering in general, what is the problem that you're trying to solve? One, and then based on repeated things that happens, or this pattern, you want to come up with some sort of solution, some sort of generalizations, algebra. And you can use this now as geometry as a way to identify that kind of thing. That makes a lot of sense. That makes a lot. Oh my god. Oh shit. So in any case, always understand the problem. If for some reason, if you're tired, whatever it might be the reason, dedicate time to or take a nap, go out, meditate, close your eyes for 15 minutes, don't do nothing, and then you come back. Because if you don't understand the problem, okay. If you don't understand that will continuously to appear over and over and over and over and over. And there's some people that say, hey, life is not a problem to solve, it's an experience to be lived. It's a mix, bro. It's not one or the other, it's a combo. Okay, so this is now the problems that we're gonna handle here with asynchronicity. It's a way to handle, and this is not exclusive to JavaScript. This is exclusive for all UI design, UI interface design. So how you can now, for example, transpolate to other areas, right? So for example, in the era here of service, dentists, lawyers, graphic designs, voice recorders, that kind of thing. Each one of them have to deal things in parallel, or at any task. Okay, we have to deal things in parallel. We have to deal things in parallel, and that is sending requests in parallel, right? So for example, if you are a dentist, okay, you have to now actually send in parallel all of this requests to your clients as a way to notify them that they come to that their date is close to, okay, that they got a close date, so be aware of that. Then you need to actually wait for them to call you back or text you back. Coordinate all of these responses. Coordinate all of these responses. Coordinate all of these responses and respond them as soon as possible, and have an order of this and have an order of this task, and have an order, man. Yeah, and make sure that all things happens in the same order, and make sure that all things happen in a particular order, in the order in which you actually now handle this. Mm-hmm.
So let me orient you to ex1.js. You'll notice I have my fake Ajax. It's mapping from a URL like file1 to some contents, and I've got some random delay in there. I've got an output utility, which is a convenient wrapper on the console.log for you to use. Here's my get file function. It makes that fake Ajax call. And this is the part where you need to start figuring out some code, because it's pretty easy to call get file 3 times in parallel. I gave you that for free. But the question is not how to coordinate the requests. The question is, how do I properly coordinate the responses? And here's some hints for you. You're going to have responses coming back because of the randomized delays. You're going to have them come back in any particular order. Some of them might come back too early, which means you're going to need to have something hold on to some state for a while. You're going to need some sort of global variable or object or array or something to hold on to responses in case you're not ready to print them. And you're going to need to figure out how to have all these callbacks sharing over that, or coordinating over that shared state, figuring out when it's okay to print something and only printing it once. All right, so we're going to take about I said 5, we'll take 10 minutes because I want to make sure everybody plays around with this. We'll take the 10 minutes, and then we are going to take an afternoon break after the 10 minutes. So we will come back.
Okay, so let's get it. Let's get into this. Okay. Where was Codepen? No, it's Code Sandbox. There you got it. I supposed to use Codepen, not this one. Yeah, I'm supposed to use this Codepen, bro. So this is my pen here. No run. This is now callbacks. This is not a call. This is dealing with asynchronicity with callbacks. This is it, right? This is it, right? So let's now take a look at the piece of code. All right. And I think it's this one, Async. I don't know why you don't actually get that. Anyway. And then you got async, and you got exercise ones. So like this, right? Okay. All right. Good. So let's run this. So this is our exercise. None of this actually care. What we really care is running this fake Ajax here, right? As a way to make these things happen, as expected. When I get file, I want to actually fire these things and just see. This is just to see if it actually is calling them properly, right? As you can see, it is working. Okay, good. Requesting file. Okay, makes sense. Good. All right. Good, good. So this is actually working. So, because the idea, this is the all busted callback, because the idea here is to see now how we're gonna handle with this asynchronicity, which is we're sending is multiple requests in parallel, and then waiting for the response, waiting for them to be response, okay, waiting for them, waiting for them, waiting for the response, okay, waiting for them to waiting for the response. If you call this requesting file 1, file 2, and file 3, the first text, the middle text, and the last text. All right. This one we have lucky. Requesting file. You know, the middle text, the first text, exactly. That time we were lucky. The last moment, the last run, we got lucky, and we cannot rely on luck, bro. No. So because of this, that we are getting is this response as whatever they want, as they see fit. So we need to find a ways to actually store this response somehow. So one way to store this response is by saying, hey, I would like to now here is store that response. It's going to call this response into an empty object here, right? Where by the time that I get that, okay, I want to now is first, because remember the whole point of this is to, okay, one of the problem here is that we need to actually handle is all of this asynchronicity. We need to handle is all of this response that can come at any point in the future. We don't know when. We need to coordinate is all of this response as they came here. Okay, we need to coordinate all of this response as they came here, and yeah, coordinate all of this response as they came here, show them as soon as possible, and show them in the proper order. So because we need to show them in the proper order, there are several ways of how you can do this. So not only that we agree that we need an object response, okay, as a way to now record this, but also when we do that, we want us to actually see, we want us to actually check in our response, right, if that file, because after all we want to store is now the key and the response with that, we want to check if the file, if there any value is there that corresponds to this file, okay, and if it's not, okay, we want them to assign that text to that. However, because we want to make things much more simple in this context, all right, which means is that we can now prefix our response by saying, hey, this is now the result, okay, or the files here. When we say, hey, in our files we got is file 1, file 2, and file 3, okay, and here we can say, hey, hey, if one of our files here match to that response, which is, hey, for so the idea here is that let's going to handle is the how we're gonna show this. How we're gonna show this in order. So by showing this in order, which is file 1, file 2, and file 3, okay, this is how we want to show this particular output. All right. So we will need to iterate through all of this. We will need to iterate through all of these elements. Why we need to so once we have this as a way to prefix this response, right? We're gonna prefix this response as a way to now have all of this sorted here, okay? So have this map where we're going to have all of this key assigned, and by the time they actually match to what it is, we are able to now assign them to the proper key. In other words, by having in our objects, by having in our response here, and a prefix of all of this response that we're getting here, by the time we get that data, or by the time we actually by the time we get that data, all right, if that data actually match with the files that we receive, then it means that this file is tied to this. So in other words, we are calling is this. So in other words, that if you want to think here in order, stack can help you to do that. So by stacking all of these files, so another way is that you say, hey, let's go to now stack all of this stack files here, all right, and anytime you call this function, what you're gonna do is to add that stack file, okay, which is push, all right. You want to add that particular file to this stack as a way to have them in order, okay. So you know that in this particular stack, you add all of these items in order. So stacks is great for adding things in order. And then you want to now check in your registry if that element, okay, if that last element that we have in our stack now match one of our response. In this case, exactly match one of them. So you want to now iterate through our exactly. So once you add, so as you add this response to this, then you want to have a particular way of keep track of looking at all of this response that you have here stored, right? As a way to check which belongs to which one, you know. So this last item that you add, right? Let's go with the brute force here. Let's go with the brute force. Let's go to the naive approach. So what we're going to do this is to say, hey, so far we need to know that we need to store is this. We need to store all of this. We need to, in this record, store all of this, right? That's what we need to know, right? That's what we need to know. So it means that we can do something like this. So response of the file. However, we need is the text, all right? Because these functions we're gonna run in a different time. Okay, these callbacks will run at a different point in time. We need to actually match this for the text. But again, because this callback is responding at some points in the future, we don't know when, okay? At some point in the future, what we can do is now populate all of our response first as the key, right? Which means that let's go to populate our response here. And by populating that, by the time it getting here, we're going to populate here is with the file here. Hey, this is file 1. But we don't know what will be the response. We don't know. We need to coordinate when this. We need to coordinate is this. We need to coordinate is this. Let's make things again. Let's make things simple. So, I know that I need to store this on my records, right? But I also need to know that I need to match this record with this. I need to coordinate here, okay? I need to handle the coordination here. I need to handle the coordination here. You know what I mean? Wait, what? I need to handle the coordination here. This is what I need to handle, the coordination. So how can I handle that? Which means that by the time these texts arrive, and because they can happen at any time in certain points, so by storing this key here, okay, I can store this key here, right? Initially. This is now the coordination aspect. By the time these asynchronous functions now get calls back, who is actually coordinating that? Who is actually tracking that? Right? We got the response here. that is actually tracking this. We're actually the response that actually tracking this. So initially this can be empty. And we know that this file, and we know, okay, that's interesting. And we know that this file here is going to we're gonna store is when this is triggered. Okay, we don't know when that happened, but it will happen. So unlike we have now a function reference to that, you know, that might be one way to do this. Unlike we have now response that, because somehow we need to actually is bind the file with that function once it is triggered, right? One way to bind that is by reference. You say, hey, now this is the reference for this, because this is the callback. And this callback now is gonna call at any random time. At any random time. Interesting. At any random time. We don't know when this will be called. We don't know when this will be executed, because we don't have that tied to that. So now that we got the file, okay, this is something that we need to, as a way to keep track of that, right? Okay. If I know what is the file, if I know my inputs here, okay, and all of this input that I'm receiving is now prefixed. So by the time that I call these functions, so by the time that I call these functions, which will run as that asynchronous operation. So by the time that I call that function, okay. What is the problem that you don't know? What is the problem that you don't? Exactly. What is the problem here? The problem here is that how can we not? This is my approach. How can we bind is this file with this function by the time it arrives, right? This might be one approach. But the other is that at the end of the day, what we care is about is the text, okay? So by now binding that text to the file, all right? In this case, is by binding this text to a file, we can now coordinate that. We have solved the coordination problem here. Yeah, we have solved the coordination problem here. So by getting this output and attach that to a so by the time this function is called, we attach them. Okay. Help me here with the solution, man, because this is a pattern that I need to actually revisit that.
Let's talk through how we might choose to solve this problem. when this callback is called, we're going to get a response back. And because of closure, we're going to know which one of the 3 files it came from. Does everybody see that?
Okay, and because of closure, we're going to see that each one of those calls will be called back.
So what I could do is I could have a handle response function that I call out to with the file name and the text that it got.
You know, it's starting to using is your, okay, this is another way to starting to using is this. Started to using your tools, man. So another thing that you can do is to create now a function called here handle, exactly by the time you have that data, okay, you can actually is bind that too. You can actually close that bind. So handle response, right? Where now this handle response, because of closure, we're gonna have access to now the file and the proper text. All right. So this handle function here, and we need to define here. By the time that this function is executed, handle response. Okay. Does everybody agree with this, right? You agree with this, right? With the fake Ajax, because of closure here, we now have access to the files and the text. Okay, which means that this is a function here, as you can see, that is now calling it inside of this. So we're going to now take care of the file and the text. So now, all right, because we get this data, as you can see here, you can get this file and the text here. So by the time you call in them, right, so now we actually have this mechanism or binding that. All right, we have now this binding mechanism here. So the coordination problem here, we quite solve this. So hey, now this belongs to this and this belongs to that and so on and so forth. But the thing here is that we want to now show them in order. That's why we need to have to define here a response object, okay, where we will need to is store this as they see fit, right? Where we'll need to store them as they see fit. This is quite interesting, and this is also another interesting here, because now we are binding is that to that. All right, in this particular case, we have now the ability to bind is that text with another one, and so on and so forth. So because we want is to now store them in order, all right. Because we want to now show them in order, we can add all of these elements into the, we can add these elements into that. So we can say, hey, let's going to add now the files and the text to that, all right. But also we need to respond as soon as possible. And we need to respond is with the proper order.
Okay. Now I could do that code directly inside of here, but I'm pushing it out to another function so that I have a little bit less nesting going on. All right, now handle response receives a file name and some contents for the file. Is everybody following that?
Mm-hmm.
What I'm going to do is need is something in enclosing scope, in this case probably the global scope, some variable, some object that is going to keep track of the responses that have come back,
The responses
in
that come
case
back.
I get a response back earlier than I'm able to render it. Everybody with me on that?
So we
I
need
might
to
get a
have
response back and be able
exactly.
to-
So right now we need is a function. We need is a object or something that allows to keep track of the response as they come back.
Immediately render it, but I'm going to
And also we need and also we need to have something that allows to respond and as soon as they can come back, and do that in order.
need something to hold on to the responses that I get back that I can't yet render. And I'm going to need to be able to basically iterate over that collection of responses when it is time to print things out and print out whatever I've gotten. So the way I'm going to do that is simply have a variable called responses. And I'm going to make it an object. This is not by any means the only way to solve these exercises. With almost everything we do in these workshops, there's many different ways to slice it. I'm only walking you through one way of modeling this mentally, okay? So handle response could say, if responses of file name, that is an object whose property is the file name, the URL that was used, if that's not already set, so maybe I would do that instead of responses of file name, maybe I'll say, if not, file name in responses. So I make sure for a fact that this function is getting called with a response that I haven't yet seen. Just takes care of.
So this function is calling with the response object that I haven't seen.
Maybe the function somehow getting double called or whatever, right? So I'm going to say this is a response that I have not yet seen yet. So the first step is definitely to add it
To add
to
that file name
my object.
with
I'm
the
storing it
contents.
into an object. Okay?
Exactly.
File name being the property location on the object, content
This is the property location of the
being
object,
the value.
and the
that I'm
content
putting
will
into
be the
it.
value here.
So if that was file 1, if this was the first time this was being called and that was file 1, I could iterate over the stuff in responses, and if there was
If this is the first time, I can iterate through the object here.
stuff to render, I could immediately render it, take it right back out of the responses object. Or I might have just put file 2 in and file 1 isn't yet there, in which case I can't go on yet. I just need to leave it there and try it again later. Okay? Keep in mind this handle response is going to be called all 3 times. It's going to be called every single time we get an AJAX response back, it's going to get called. So it's going to have an opportunity to be called for all 3, but we're not sure which order. There's 6 different ways that this can happen, or 3 different ways, or whatever. There's a lot of different ways that this can happen, and we're not sure which order it's going to happen in. So we are trying to coordinate that or normalizing that concurrence all 3 times. It's going to be called every single time we get an AJAX response back, it's going to get called. So it's going to have an opportunity to be called for all 3, but we're not sure which order. There's 6 different ways that this can happen, or 3 different ways, or whatever. There's a lot of different ways that this can happen, and we're not sure which order it's going to happen in. So we are trying to coordinate that or normalizing that concurrency. So after I've made sure that my response has been stored into my responses, the contents have been stored in the responses, now I could simply start out with an array. Now this is a simple cheat way of doing it. There are, of course, other ways where I could have kept those in a external location in some way, but I'm just trying to come up with the simplest way of solving this problem. If I know what those URLs are and I know what order they're supposed to happen in, I could have produced this array by the order that they were requested in, if that's what I wanted. Again, just taking the simple way. Let's assume that I know.
Exactly, taking a simple assuming, because now here, thanks to this particular order, you can actually is now calling and check is the coordination problem. So you can use this now an array for coordination
file 1,
problems
file 2, file 3 need to happen in
sorting
this
them.
order. So now I can just say for var I equals 0, I less than arr.length, and maybe instead of arr, maybe I'll call this file names. I++. So I'm going to look at file 1. It's going to be file names of I, which the first iteration is going to be file 1. I'm going to say if that is in the responses object. So file names of I is in responses.
Exactly. So after this, what you want exactly? This is now the first time to actually check if that content is. So you're checking that, you're adding that to this global object here. Exactly, it cannot be on a function, because once the function is over, you lose that data. So again, this is one way to solve this. Okay, and not only that, that after we receive that data, we need to somehow is to coordinate is the response in order. So when we talk about in order, we can use it as a stack or as an array. In this case, we're using is now an array of this, all right, as a way to say, hey, this is now the way in which I want you to is this is now the way in which I want you to output the response, okay, in a particular order.
Or it's not in responses. Can anybody guess what I'm going to do if it's not in responses? Break the for loop.
So if you're not in the response,
Actually, in this case,
get out of here, because you don't want to show something to.
for convenience sake, I'm just going to return. Just completely empty out. So whichever case I'm in, whether I'm looking at file 1 and it's not in there, or I'm looking at file 2 and it's not in there, or I'm looking at file 3 and it's not in there, I got
that whatever time I'm looking for that particular file, because I already store all of this in the record. Look at this, because I already store all of this in the record, and then what I'm gonna do is to depending on how they store that, I want to now iterate through this in order as a way to now is show them the way in the way they were called.
I had nothing left to render on this particular pass through my responses.
In the way they were called, which is by the time this actually.
Because I know if it's not there, then I'm not going to render anything else. So I can take advantage of an early return here. If it is in there, I can say if it's still.
So if this file name is the same.
For example, I can say if it's still a truthy value, or I could say if it's still a string. And you'll see why I'm saying that in a moment.
Okay. So is this file now is in the response, all right, which is something that we are getting here. So file names, okay. So is this elements that are iterating is now the response? No, I don't want you to return this. Yeah, I want you to do nothing. I want you to return nothing here. Hey, is this is on this C and the 2, right? Is this his file 2 is in the responses? Then I want to now return something.
If it's still a string, then I know it's time to go ahead and render this. So I'll say file names. I'll say responses of file names of I. This one is going to need to be the same thing. This is responses of file names of I. Now that I've rendered it, I want to leave the entry in there, but I want to mark it as having been rendered. So a simple way of marking it as having been rendered is to change it from being the text to something like false. So the entry is still in the object, which means I'm not going to try to re-add it in there. But I'm not going to try to render it over and over again because it's going to fail this typo check. There's a million different ways that you could choose to implement this logic. I'm just showing you one possible way of saying, I'm looping over this list and I'm checking to see whether I need to render something. At the end of this, if I have rendered all 3 of them, then I can finally output my complete message. This function is going to get called for each of those 3 times. The happy path.
Exactly. this function we're gonna get called the 3 times, and the happy path
is that it gets called once with file 1, and then once with file 2, and then once with file 3, and it never needs to get to this early return thing. It never needs to even store anything. But it might get called once with file 3 first, and then once with file 2 first, and then finally the third time with file 1, where it hasn't rendered anything yet. And that third time, when it goes to loop through, it's going to say, I do have a file 1 rendered, I do have a file 2 rendered, I do have a file 3. So whichever way these come in, I'm always going to render ASAP, but only in the correct articulated order. Yes?
Sorry, maybe I understood the problem statement wrong, but I thought you said you wanted to do it by ordering the callbacks. Or did you not say that?
What do you mean?
So I was thinking that maybe we would have different callbacks for all the get files, and then somehow we would order them. That's how
we do have different callbacks for all the get files.
Okay, that's fine.
I'm not sure I understand what you mean.
I wasn't expecting this implementation.
Did you solve it a different way?
No, I couldn't.
Okay.
I was thinking more in the lines of promises, but just to order the callbacks in some way, and I couldn't come up with anything.
Well, the only way you're going to end up ordering the callbacks is to have sequential requesting, where you don't.
Just to order the callbacks in some way, and I couldn't come up with anything.
Well, the only way you're going to end up ordering the callbacks is to have sequential requesting, where you don't even request file 2 until after file 1 is finished, which violates one of the fundamental premises of the setup of the problem, which is to call them in order. That's why that's there, because it's easy if you just want to do serial requesting. But it's the parallel requesting that causes this concurrency coordination to be more complex.
Exactly, because it's not this. You have to cause this concurrency coordination that it needs to be keep track of this file, and not only that, that by the time you are calling this particular function here, you say, all right, this is the first time I'm now adding is this element, and if this element is not. If the file, the happy path is this, hey, the happy path is the file, if file 1 gets is here, now I'm going to actually print that in the proper order. Similar for file 2, but this is as a way to hard code this, right? And you are now hard coding is this.
Okay. The point that's really being made here is that 3 independent callbacks have to share some closured state.
3 independent callbacks here had to share some global state.
Even if it's a global variable, they're going to have to share some closured state to coordinate themselves. That's just, there's no other way around it. Whether it's the global state or whether there's some other wrapper or that variable's passed in. I mean, no matter how you slice it, there's going to have to be some shared variable across all 3 callbacks. And they're going to have to potentially store something in that variable until it's time to come back and get it. That's what we mean by saying that we're coordinating concurrencies, that we're managing that time state complexity. And we can see that there's a solution to it, but I don't think anybody would argue that this is a good, graceful solution to it. Right? It's ugly, right? But it gets the job done. And I can't tell you many hundreds of times I've solved similar problems in the past where the only tool I had available to me was functions and closured variables. So we can get the job done, even complex scenarios. But this isn't the ideal pattern. And that's why I'm walking you through it. I'm showing you first the pain points that we've been dealing with to motivate why we want better patterns. Is everybody with me on that? Any other questions about exercise?
Not only this is ugly, but also it's quite hard to read, bro.
We're going to get to come back to the exact same problem domain over and over and over again, okay? You'll get better and better at solving this problem with better patterns.
By the way, I'm not convinced that you're going to return, like if it comes back file 2, file 1, file 3, I think you might get the complete even after file 2, because won't it fall through?
I'm sorry, what?
Won't it get file 2? It should.
You're still losing me.
You're tripping me.
Maybe over a break we can talk through it.
Yeah.
I mean, you can compare what I've typed here to what I typed in the solution file.
Oh my god, that was. So here is that it's not here that you need the response, because this is only gonna live is now here. It makes sense. This needs to live, right? This need to live somehow is here. But somehow we need to store this response here. And anytime we actually is now call this and say, hey, is the response is the file in response, or in this case, say if this file is not in the response, say file name, so it to be the content. Hey, if this file name is not in the response, which means that one of the great thing of actually looking at this is by saying, hey, the in operator in MDN, that's what you need, is to more hand practical approach of this, is that is the in operator here. You say, hey, it's gonna check if this property is in the specified object or in the prototype change. Okay, so hey, if this property is in this object or in the prototype change, okay, makes sense. So now if it's not, let's go to add that, which is response of the file name. This is the location, file name, and the content, right? The contents employed. So now if this function is being called here several times here, the idea here is to actually make it much more easy to handle this, is that now that we know this record where we are going to coordinate is their files, okay, right, as they came in. Now it is time. So now that we have this record where we actually are tracking is the URL with the AJAX request or with the response, and in this case the particular code that we trigger, or the as a way to map as a way to map is the asynchronous callbacks, or as a way to map is the result from the asynchronous callback. Okay, this is what we're doing here to keep track of that. And then when it comes to actually show this in order, is when we define is this variable here called the array. Why is that? This is a particular solution that we have here for now. Being able to handle this in order, which means that by the time we are now going to call this function, if this are in this particular order, which means if the file one actually match the file name, that's when we're going to now print that out. In other words, by iterating through this array and say of the array, the array dot length, which is I minus the array dot length e plus plus. By doing this, okay, so now what we're doing is, hey, if this is the file name 1, oh shit, look at this, your hard coding is the order this. Let's say, hey, if the respond, or in this case we can say, hey, is the file, is the array in that position, or in this case, if this is the first element, all right, if file name 1 is in, so if this key is now on the response object, all right, now we're going to actually handle this or this, right? Which means that if this is the file 1, then I want you to now return the output here. If it's not, I don't want to do anything here, which is return here or break the loop. But in this case, since we are in a function, we are returning that. However, if this it is, okay, if this key is now in the response, which is in this particular order that we're iterating through, now we can say, hey, let's go into now is, well, yes, a way to make more sense, file names. That's a way to make more sense here. Hey, file names is in the response. Then we check now if this is now a string for that, as a way to only show that by the time we already show them, or only show them once, which is, hey, if the file name is in response, we say, hey, I want now to check the value of that, of the response, all right, of the file names. And of the file name at that position, okay. If this is type of string, okay. If it's at a string, then what I can say is now call this output function. That's gonna output that. So output function, that is the response file name in there. And then he mentions that because you don't want to actually output this over and over and over and over, you can now as a way to mark this as read, you say response of the file name in that so the key of that file name will be now true, will be now true, which means that you already show this. Holy moly. And then after that, at the end of this, which is at the last of this call, so by the time this is done, okay, then we want us to call now is the complete, which is, hey, I want you now console.log is complete. So the happy path is that is by the first time we get now the file names, by the first time that we get the file name and the context that they're actually the match with the order, you're gonna print this. You're gonna print that, the same for the file 2 and the same for the file 3. The other is that, hey, if we receive that in different orders, okay, by the last time, so by the time that we are now, so by the last time that we return, that we get is now the file 3, all right, then we're gonna check is that and show them in the proper order. This is not to see how the coordination is going on, bro. Holy crap. Holy crap, bro. Or you can say it's not output complete. Okay, output complete. Holy crap, bro. Oh, it's like a type of. It's a type of. It's a type of this is equal to string. There you got it. Because it's file names. That's right. For this. So by the time we call this response object with the file name, we're calling is this. To false. But this is not playing with JavaScript here. So if the type of response of the file names is equal to string, or in this case loosely, and it takes quite amount of time, but it's now showing in order. Oh no, but this is the way of how am I storing this file names and the contents, right? This is not response of that file name here, and then I got the file names dot length. I'm iterating to the file names. That's right. In response, exactly. Hey, this is here type of response file names of the. Yeah, if the file's name, if file name is in response, I think is or return false. But it can render that. Okay. Because this is now when you change the logic here. This is when you change the logic here, that you say, hey, this is the value that I have here is true, is different to true. I want you to now run this. The response is a global object of that. Exactly. If file is in response, then I want to check if that is different from true. And it's using var for this. As a way to scope that globally. But I think this must be something like this, bro. And also, that's a very interesting thing, bro. This actually doesn't work as expected. And now this particular code, it will. Because it's file and text. So, if the file name here, which is the one value, is in response, then I want to make sure that the value in there is different from true. It means that it's a string to actually render this. In other words, responses if this response is different from true, I want to output that and transform that response file name into a false. as a way to mark them as visited. Enough, my friend. So if that response is not in that, I want you to now populate that. And then to actually access through in order and run them in order, then you're gonna do this. File name's length here, if that file name is in response, if that file name is in response, okay, response needs to be rendered. Exactly. If that file name needs to respond, is this in the response? So what I'm doing is trying to access to these values. Can you? There's a friction. Okay. There's a friction. I get it. Eliminate the friction. Thank you. Is this file I is in the response? Is in the response object? If it is, okay. So now let me actually render that. So now let me actually render that. Output response at the file name at that position. But in this case, say undefined, 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 because this is not what is passing through this. So again, let's go check this logic. Here we are now getting is here we're checking, hey, if this is response file name, is this property doesn't exist, if there is no value here with this property, hey, let me now add this. Then what I'm going to do is to check that in order. I want to add them is in a particular order, which is in this. I want to add them in a particular order. Are we accessing some keyword that I don't know aware of? Oh, I get it. Exactly. My logic is here as true. because once I read this file, I want to mark them true because I already read them. However, this is still not working as expected. This is quite puzzling to me. Mhm. Mhm. Okay, Jesus. File names. Always is a human error. And then you're gonna get that as expected. Is file names here. Say first text, middle text, then false and false. Somehow is passing through this. It is very subtle, bro. And of course, this actually doesn't help us here that much. The other is that if this file name is not in response, let's gonna add this. So somehow it finds its way to pass through that. But as you can see here, the idea with this exercise is that see how you can now have a global store, a closure here as a way to not only is keep track of all of this response and also show them in order. Mm-hmm.
Complete.
Any other questions about exercise? So we can get the job done, even companies that we're managing that time. I mean, no matter how you slice it, there's going to have to. The point that's really complex. Okay. The point that's really being made here is that 3 independent callbacks have to share some closured state.
Mm-hmm. 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 Hurry. Digo, ya. The point of this is that if you need to the point of this is that you need to share some sort of state to coordinate themselves.
The point that's really complex. Okay. The point that's really being made here is that 3 independent callbacks have to share some closured state.
The point of this is the point of this is that 3 independent callbacks have to share some closure state as a way to keep track them, or as a way to keep track them and coordinate their outputs. Oh crap.
Even if it's a global variable, they're going to have to share some closured state to coordinate themselves. There's no other way around it. Whether it's the global state or whether there's some other wrapper or that variable's passed in. I mean, no matter how you slice it, there's going to have to be some shared variable across all 3 callbacks. And they're going to have to potentially store something in that variable until it's time to come back and get it. That's what we mean by saying that we're coordinating concurrency, is that we're managing that time state complexity. And we can see that there's a solution to it, but I don't think anybody would argue that this is a good, graceful solution to it. Right? It's ugly, right? But it gets the job done. And I can't tell you many hundreds of times I've solved similar problems in the past where the only tool I had available to me was functions and closured variables. So we can get the job done, even complex scenarios. But this isn't the ideal pattern. And that's why I'm walking you through it. I'm showing you first the pain points that we've been dealing with to motivate why we want better patterns. Is everybody with me on that?
So this exercise is just a way to show the pain point of coordinating a synchronicity or coordinating concurrency. This exercise is just a way to show the pain point of coordinating concurrency and the need for better patterns. That's a TLDR. And that'll be all for this video. Take care. Bye-bye.